Hello everyone and welcome to another update for the incubation engineering at GitLab for MLOps. My name is Eduardo and today we're going to talk about pipelines as part of the MLOps create stage. I've been talking about this a little bit on my past few updates on some of the efforts that I have already done or some that I want to do, but I've never taken the time to talk about this from a higher bird's eye, eagle eye view. And I want to talk today about the vision that I have for this. So where do we want to get? Why is this important for MLOps? How pipelines, how data scientists create, and how pipelines fit into this create process. This is going to be a longer update than usual, but hopefully it's going to be an interesting one. So for those that don't know, at GitLab, we kind of split the DevOps into a lot of different stages. So you have create, plan, verify, and today I'm going to talk specifically about how data scientists create. So if you want to learn more about the stages, you can follow the link on the previous slide, but we're going to talk about how data scientists create. First and foremost, these are the tools of trade. Data scientists mostly use Python, R, and Jupyter to create their things. And now whatever IDE they use for Python and R scripts as well, like RStudio, VS Code, and whatnot. But Python, R, and Jupyter are the de facto almost tools for the trade. And something very interesting about how data scientists create in Jupyter is that it's very iteration by default. It's very iterative by default. So you have one cell that you edit, and then you run the next cell, and then you go back to the previous cell, and then you go forward and backwards and forward. And from this, you can already see how pipelines are taking shape. Think about that each of these steps, each of these cells is a job. So you can already think that this is shaping its way towards a pipeline. But not only that, even when we don't use Jupyter or whatever, it's very common that we need remote code execution. So, for example, I need to run I need to train a model, but sometimes training models can take 8 hours or a lot of time, and I want to run multiple trainings at the same time. So I can delegate this into a cluster or something like that. And this is part, and I'm not talking here about CI/CD. I'm talking here about creation. This sometimes happens when I don't even have the code on Git yet. This is still living in my computer, in my local development setup. So for example, here with Ray is a distributed solution. Is a solution for, it's a company that implements distributed solutions for data science. You see here they already have, for example, ray.remote that tells that function should execute on a specific box or a remote instance. Same thing here with Kubeflow pipelines, which is also commonly used by data scientists to implement this pipeline. So you build a DAG to run your data science workflows. And again, this is on the create. We're not talking about CI/CD. This is way before CI/CD even start to take shape. Not only that, think about model tuning. When we tune models, when you tune hyperparameters, we run a search optimization where every step is training a model. So you can see how often we have to train a model right from the create stage, and training a model is not cheap. It's not fast. It's often not able to run on your own machine. You have to offload this into a more powerful machine that has better GPU or whatnot. Also, model debugging. So, for example, if I want to debug some bias variance issues with my model, I can plot graphs like this. But note that each point on this graph is a trained model in itself. Not only that, it's often a collection of trained models. So you might have each point is the result of 5, 6, 7, 8 models being trained so that you can take an average for that specific value. So you can see already, you get the feeling of how often we get this and why it is important, and how pipelines come very, very early on the MLOps lifecycle, DevOps lifecycle. And let's talk just to show a little bit more how this is quite crazy. This is all the offerings from Ray from their website. They have all of these great libraries, all of these great products. Only 2 of them are not create. All of them are on the create stage already. You have fetching the data, which is already on the create. You have training models, which are already on the create. You have tuning mods, which is already on the create. RLib is already, reinforcement learning is already on the create. All the distributed libraries that they have is already on create. So, yeah, it's just essential for MLOps, for pipelines to be part of creates, to be seen from the create perspective, not only later down the problem. And on this space, there are very big user pain points that I have not been addressed. First of all, it's a fragmented market. You have a lot of open source tools that each one does something small or doesn't do very well or whatever, but they all require you to learn that specific tool. It all require you to maintain that specific tool. They not always have the best UI, and it's just really complicated for a data scientist to come in and choose a tool on this area or bring in, because they're also not part of the infrastructure team often. You have the infrastructure team and you have the data science team, and communication is not always the best between them in some companies. So it's really hard for the data scientists to get the tooling that they want. And I think we can fill in this space. I think we have a lot of opportunity here for GitLab to grow into this area. So we are already part of the stack of many of the companies that we can look at. So there's no additional cost of maintaining this on another tool on the stack. We have great documentation. We have top-notch UI for pipelines, a lot better than all the tools that I've surveyed in the past. We have a big community, and we can be the same tool to have create, verify, and deploy following the same pattern for pipelines for the data scientist. So the problem, or not the problem, but the situation that we have right now is that pipelines are on the verify stage. They were created, the UI was created, the use cases were created with pipelines as part of the CI/CD. And what we need to do is expand this. Pipelines as part of both the verify but also of the create stage. When we take the glasses that only look at this from the verify and we start looking from the create stage, then we can start seeing what other features that we can and how can we prove this tooling for this use case specifically. So, for example, some of the things that we can do here is we have the whole infrastructure of GitLab runners already implemented. We have the DevOps team on the company of the users already knows how to create a box or a runner or anything. We can use these GitLab runners as backend for remote code execution. It also means that while I'm iterating, imagine that some jobs can take 6, 7, 8 hours. I'm not going to be committing every change that I make so that it gets published or it starts a pipeline only on git commit. No, it needs to be faster. The iteration process needs to be faster, and I need to be able to tell when should something run and when should I want to start only after a specific job or only run some specific jobs. And finally, since I'm already creating pipelines for create, why not just reuse the same pipelines for verify? So I already created a pipeline before. I already have my steps, already have my stages over there. Why can't I just port that pipeline to the CI/CD part. So when I talk about runners, I talk about GitLab as a backend. GitLab, when you say, for example, ray.remote, call a GitLab runner, or not ray.remote, suppose that we have a GitLab.remote, for example, call a runner that will run the job and return to the local machine the answer, so that it connects, it gets all answers together. Or if I'm working on a Jupyter notebook, it can be that each cell runs remotely on a runner, even though the document is in a server itself. The code is executed in a different runner, which is a lot more powerful, which has GPU, which has, I don't know how much memory you need for that, but this is what I mean. But the problem here is that pipeline executions right now is heavily coupled to the CI and Git flow. You can't really do this kind of process without going through the Git flow, without going through the git commit, git push, start a pipeline, because you need to push code changes as well. So you're running pipelines where the code is not on a Git repository yet. It's still on your local machine. It's still running over there. It only exists there. It's not on the repository yet. So current setup of GitLab doesn't work for this. It's not prepared for this. It was never coded with this use case in mind. What I did so far was Scyther. Scyther was a POC that I created a few weeks ago, where you have a local code. I created a pre-configured repository project on GitLab, and I use a lot of creative engineering to send code to this through a triggered dynamic child pipeline that is run on the runner, but my local process is still watching the runner, and once the runner is done, returns the results. So from the perspective of the developer, or of who is working on the code, everything happens on their machine. They don't need to open GitLab for anything. Everything is in their local. It's still very limited, very hacky, but it shows a little bit how we can do this. Scyther can easily be evolved into having, for example, into our VS Code plugin, so that we can run pipelines directly on the repository on GitLab. The second problem: imagine that I have this pipeline with 5 steps. I'm testing them out, or I'm not even testing, I'm actually working on them, and pipeline D fails. Now suppose that C is training, A is preparing the environment, B is fetching the data, C is training the model, and D is uploading the model. Suppose that the first 3 steps take 24 hours to finish, which is not uncommon at all. I don't want to run A, B, C again once I fix D. Suppose that I have to change D. If I have to change D, I would have to run everything again, and I don't want that. Rerunning entire pipelines for MLOps is really, really costly, and one way to avoid this is with the concept of stub jobs, which is, okay, if I'm going to rerun from D, let's find the last successful run of C and use the output of that pipeline so that I can run the new D on top of it. I have an epic for this over there, which I'm gathering not support, but feedback on this, how we could approach this problem, how we could work around minimum viable products for this. But this is really game-changing for MLOps and for many other use cases, but for MLOps this is very important. It allows teams to focus on iterating on only one step of the time, one step at a time, and reuse what was done before. So Kubeflow implements this with Cache. Plumber implements this as well. A lot of the pipeline tooling that we have here already implements this with in some way or another. But it's quite complicated to do this with GitLab because you need to do this with a new commit. You can rerun jobs, failed jobs on GitLab, but as long as they are part of the same commit. Here we are talking about different commits. Another thing is, okay, I have Jupyter, Python, or I created my data pipeline, my machine learning pipeline, and now I want to go and create a CI. I have to manually transform that into a YAML that goes into the CI, but why would I need to do that? Why is this necessary? Why couldn't I just have something that automatically takes the pipeline that I already have created, translates into the YAML that GitLab is going to read and run that for me? No need to transform anything, works by default, speaks the language of the user. So this is what Glitter is. This is also another POC that I have. It currently transforms a Jupyter notebook into a GitLab pipeline. Is also very limited, but it also showcases a little bit of the experience that we can offer users on this side. So just a summary here. Pipelines, you cannot talk about MLOps and not talk about pipelines in the create stage. It's just not possible. You need pipelines in the create stage. It's just so important from the beginning of your ML, of working on an ML model, of working on a data science use case, that starting from data ops already, it's already in there. So we need to look a little bit, step back a little bit and put these new goggles for pipelines, looking at it from the create stage. What are the pain points when creating pipeline? Because when you use it at the verify, you code a pipeline once and then it keeps running for all the commits or whatnot. It's like the usability is a lot more reusable than when you talk about create stage. Create stage, you're always creating a new pipeline. You always create a new pipeline. You start a new piece of code, new pipeline. You start a new function, new step on the pipeline. So you're changing the pipelines a lot more than you do on the verify stage, and this exacerbates a lot of the users' pain point a lot of the pain points users have with it. So just to summarize what I've been working on and what I want to work on, Citer is about decoupling running a pipeline from CI. It's about decoupling running running the pipeline from Git flow. It's about running a pipeline that is not where the code is not even the configuration or the code or the necessary files are even on the repository yet. So I need to upload these files or download from somewhere else. Running pipelines with stub jobs is about making it. It's about reusing. It's about optimizing time and resource usage for our users. So it's about making sure that it only runs what it needs to be run when iterating. And Glitter is about making it that simple to transform a pipeline that you already had on the create stage into a CI configuration that you can run on the verified stage. And that's what I had for today. Thanks for sticking with me. Have a good one. Bye.